So, welcome to the first video on statistics, and what we're going to do is we're going to start by talking about the two basic vocabulary terms, which are what is statistics and what are data. And so right off the bat we can discover that data is really information that comes from a count, an observation, a measurement, or a response. So let me give you an example of each one of those. A count would be like how many people are smokers in class or non-smokers in class. All right? An observation would be, an example of that would be how many, not how many, that's a count. So an observation, what would I do? Oh, I would be looking at the effect of a new drug on a patient. That would be an observation. So does this new drug help them lose weight or does it help them gain weight? So what's a measurement? Well, how tall are you? How heavy do you weigh? What's your shoe size? Those are all measurements. And a response would be, for instance, who's your preference in the next presidential election? Or what issues are important to you in the next election cycle? So those are more responses to questions. You can count those responses as well. But that's the difference between a count, an observation, a measurement, or a response. But it's those four categories that create what we call data. Finally, what is statistics? Well, statistics is essentially the science of collecting, analyzing, and interpreting data. So collecting data. How are you going to collect it? Well, are you going to make a survey? Are you going to do an experiment and record the results? Are you going to roll a set of dice 10 times? Are you going to keep track of how many cards are happening in a game of poker or blackjack? All right? How do you analyze data? Well, analyzing data is typically about numerical stuff. What's the average? How spread out is this data? What kind of graph can I make? So analyzing data. And then finally, interpreting data. Well, what does it mean if 10 out of every 12 students don't do their homework? What kind of interpretation can we come to that? Is that unusual? Is it a common thing that happens? All right? So knowing what the statistics is and knowing these three aspects of statistics and knowing data and these four types of ways we collect data, that will help you in the types of problems that we approach here in the future. And what I would like for you to do is come up with an example of your own for each of these 7 things. On data, these 4 things, and on statistics, these 4, and then you can tell me in class tomorrow. So the next thing we want to talk about is there are 2 types of data sets. The first data set is called a population, and the second type of data set is called a sample. Now it's very important that you're able to tell the difference between these two when you read problems and have to decide. So what is a population? Well, first of all, a population is a collection of all data in an area of interest. So what do we mean by that? A collection of all data. The key word here is all. Well, suppose I want to know about the population of Hug High School students. And suppose I want to know the ethnic makeup of the student body at Hug campus. Well, if I only count the students in our classroom and find out that, well, we have 20 of Hispanic descent and 2 of African American descent and 2 of Tongan descent and 2 of mixed race descent and 3 of European Caucasian descent, then, and I try to generalize that to the population, then that's not a really good idea of what a population is. A population has to be a collection of all the data in the area of interest. So I would have to actually count the racial diversity of all the students on the campus and get all outcomes, responses, measurements, or counts in my area of interest. Okay? So when I say data, remember what we did on the first page. Observations, counts, measurement, or responses. All right? So what's a sample? A sample is just a subset of a population. Now, I may want to study the racial makeup of all the students on the Hug campus. However, maybe it's very difficult for me to interview all 1,300. So I'm back. Buzzer went off here at school and the announcement played and interrupted me. But a sample's the subset of the whole population. And I still want to study the population. That's my area of interest, the racial makeup of students on the Hug campus. But in order for me to gather my data, what I want to do is I'm only going to gather it from a small portion of that population. So maybe I'll take some sort of sample, some subset of 50 students, or maybe I'll just use U28 in this classroom because it's easy. So the real question then becomes, well, how do you choose a good sample? How do you do that? Well, at this point we're not as concerned about that, and that's actually not the focus of our course very much. We will talk about it a little. But our focus today is what's a subset? It's a small group of the whole population. Well, one of the things that we have to do is we have a population or a sample and we're trying to collect this data, this information we're interested in from these groups. And what we want to know about are some kind of numerical descriptions. And you guys have probably heard these things. You'd like to know what the average age is or the average shoe size. You've probably heard the word median and mode, and we'll talk about those later. But we want to know some numerical measurement of a population or a sample. And these numerical measurements have names. If the numerical measurement comes from a population, then the numerical measurement is called a parameter. But if the numerical measurement comes from a sample, it is called a statistic. All right? So if we go back to our Hug High School example of the racial makeup of students, suppose I find that 20% of the students on campus are African American. And I did that by counting a roster of all the students on campus and just looking at their racial makeup. Well, if I did that, that would be a parameter, okay? Because I found 20% were African American. However, if I took a sample of our class, and we have Cliff and Katie in class, so Cliff and Katie are the only African Americans, then Cliff and Katie from our sample, which is our classroom, that would be 2 out of 28. which is approximately 7%. So we would then say, well, based on our sample statistic of 7%, we would estimate the population parameter that the number of African Americans on campus, or the percent, is only 7%. So generally what we want to do in statistics is we want to take samples to help us estimate parameters. So when you read these problems in class, you want to make sure, is it a sample trying to estimate the parameter, or is it just the population and I'm trying to find the parameter? So once you figure that out, then you'll know which is which. So that's population and sample. And then finally, just two other brief. The first one is the idea of descriptive statistics. That's where we organize, summarize, and display data. So in our first couple of chapters, this is really about how do you find the numbers and make the pictures. Numbers and pictures, that's what descriptive statistics is. And that's most what this class is concerned with. So we're going to do that. The second part of statistics in our later chapters is called inferential statistics. And inferential statistics is about using the descriptions that you found to draw conclusions about the population. So in other words, your descriptive statistics is really going to organize, summarize, and display data using numbers and pictures of samples. And inferential statistics is then going to draw conclusions using those things that you have found in the descriptive statistics. And this is where probability is going to help us make inferences. Because it turns out very small probabilities have huge consequences in statistics. And we'll talk about that more when we get there. So thanks. This is the end of the video. There are a few examples in the book. I may touch on them in class, and we'll do that. But generally, you just have to write definitions, answer true and false questions, and then determine whether what you're looking at is a sample or a population. And so this will be section 1.1, and probably finish it here at this first time. All right, talk to you later. Bye.